Hey everyone. In this video, we're going to break down asymptotes. First, we're going to look at what an asymptote is. We're going to discuss the different types of asymptotes that exist. Then we'll explore how to identify asymptotes in reciprocal functions. And finally, we'll look at asymptotes in exponential functions. Okay, so let's just start. What is an asymptote? We first need to understand that. An asymptote is a line on a graph that a curve gets closer and closer to but never actually touches. So we say that the graph discontinues at that point, or there's a break in the graph. Okay? Now there are three types of asymptotes. The first one is horizontal asymptote. Let's have a look at some quick visuals. Okay, so see, notice how this green graph flattens out as it approaches this line, this pink broken line. This pink broken line is the asymptote. This is the horizontal asymptote. Okay, so the graph is going to flatten and it's going to get closer and closer to this pink line, but it is never actually going to intersect this line. Okay, now here is a vertical asymptote. See how the graph shoots up near a specific x value. But again, it's not going to cross this pink broken line. This pink line is the vertical asymptote. Okay? And here is the slant or oblique asymptote where the curve leans towards a slanted line. However, again, it is not going to cross or intersect this line. Now, the good news, slant or oblique asymptotes are not mentioned in our syllabus. So we are going to skip those for now, and we're just going to focus on horizontal and vertical asymptotes. So this is a horizontal asymptote, this is a vertical asymptote. You might be asked in an exam to find the equation of an asymptote. Okay, now I hope all of you remember from coordinate geometry that the equation of a vertical line is always in the form, yes, x is equals to a constant. Okay, in this particular case, the equation of the asymptote will be x is equals to c. Okay, and for horizontal lines, our equations are always in the form y is equals to a constant. In this case, in this particular graph, the equation of the asymptote will be y is equals to b. But don't worry about how to find those just yet. We'll get into that in the next section. Right now, you just need to understand what an asymptote is and how it looks on a graph. Think of it like this. An asymptote is a line that your function will never cross. Why not? Because the function can't actually reach that value. It will become undefined or grows infinitely large or small near that line. If you're still a little unsure, no worries, just pause the video, go back and watch this section again before moving on. This part is super important for your understanding. Now, the types of functions that usually have asymptotes are reciprocal functions, squared reciprocal functions, and exponential functions. We'll first focus on reciprocal and squared reciprocal functions. I'm going to assume you're already familiar with the basic shape of their graphs. If not, feel free to pause and review that quickly. Okay? All right, let's first tackle the reciprocal functions and then we'll move on to exponential functions a bit later. Let's have a look at the reciprocal function and try to understand why we have asymptotes at certain positions. Let's start with the vertical asymptote. To find a vertical asymptote, you set the denominator equal to 0 because division by 0 is undefined and that's where the graph just shoots off, okay? And there's a break in the graph. So in this case, we have x in the denominator, so x cannot be equal to 0. So what is the equation of our vertical asymptote? That is x is equals to 0, which is basically the y-axis. Okay? Just try and understand the concept and then we will delve into the workings of how we can evaluate the equations later. Also, the numerator here is equal to 1, right? The numerator here is equal to 1 and a fraction can only be 0 if we have a 0 in the numerator, which is not possible in this case. So we know that 1 over x cannot equal 0, which means y cannot equal 0. So that is the equation of our horizontal asymptote. So x is equals to 0 is the y-axis, and it is the vertical asymptote. Y is equals to 0 is the x-axis, and that is the horizontal asymptote. Okay, similarly, same goes here. This is the squared reciprocal function. Again, we're going to equate the denominator to 0, and we get x is equals to 0. So that is the equation, that is the equation of our vertical asymptote. And since we have a 1 in the numerator, the fraction cannot be equal to 0. So y is equals to 0 is a horizontal asymptote. Okay. Let's try a few more examples together. And each time we're going to just set the denominator equal to 0 and solve for x. Okay. So let's begin with this. What we're going to do now is that we are first going to focus on how to find vertical asymptotes. Okay, let's become an expert of that, and then we are going to move on to horizontal ones. So for vertical asymptotes, what is the technique that we are going to follow? We are just going to set our denominator equal to 0. Okay, so what is the denominator here? This is the denominator. We're just going to pick that up, and we're going to equate that to 0. X is equals to 3. So what is the equation of the vertical asymptote in question number 1 or example number 1? It is x is equals to 3. So आपका ग्राफ पता किस तरह का बनेगा? ये आपका एक ग्राफ है ना? So at x is equals to 3 यहाँ पे होगा और ये आपका इस तरह का बनेगा कुछ ग्राफ. ठीक है? इस तरह का. We're going to learn the sketching of these graphs in another video. इस पे मैं focus अभी नहीं कर रही. I will definitely make a video where I'm going to guide you guys how to sketch graphs of reciprocal functions, quadratic functions, cubic, and exponential, especially exponential. I don't know why I feel exponential functions is going to be an important test topic this year. Okay, let's try the second example, which is a squared reciprocal function. So what is the denominator here? X minus 2 whole square. Let's equate that to 0. X minus 2 whole square is equals to 0. We take the square to the other side, it becomes under root. Since we have a 0 there, it's going to remain 0. X is equals to 2. So what is the equation of a vertical asymptote in this case? It is x is equals to 2. Okay, the third example. What is the denominator? X square minus 16. We're going to equate that to 0. X square is equals to 16. We're going to take the square to the other side, take the under root of 16, and we obviously add a plus minus before the under root, so x is equals to plus minus 4. So we have equations of two vertical asymptotes here. Plus 4, x is equals to plus 4, and x is equals to negative 4. Okay? Let's tackle one more example before moving on to horizontal asymptotes. Okay, so in this case, first you're going to simplify your function. Always simplify your function. So this becomes 2. And in the denominator, we're going to solve this using factorization. I hope all of us are comfortable with middle term breaking. Again, if you have a problem with this, please review it. And I shall make a video explaining this concept later. So through middle term breaking, we have simplified this expression to this, okay? So x minus 2 over x minus 5. We can cancel these two out, and what are we left with? 3 over x minus 5. So now, what do we have in the denominator? We have x minus 5. We're going to equate the denominator to 0, and we get x is equals to 5. So this is the equation of a vertical asymptote for the given function. Okay, so I hope you are absolutely clear about how we are going to find the equations of vertical asymptotes, right? And now we are going to move on to horizontal asymptotes. Okay, before moving on, I need to work on one last example because I want you to notice something important. So let's have a look at this example. 3x squared plus x minus 5 over x squared plus 1. Okay, so to find the vertical asymptote, we're going to, as usual, equate the denominator to 1. To 0. So x squared plus 1 is equals to 0. X squared is equals to negative 1. Now, the function involves a square root of a negative number, and as you probably know, square roots of negative numbers don't exist in real life. So in that case, the function doesn't have a vertical asymptote because it's not even defined for those x values. Okay? So in this case, we're going to state that this function has no vertical asymptotes. Okay, now let's try and understand how to find horizontal asymptotes. So for vertical asymptotes, I hope all of us are clear that we need to equate the denominator to 0 and then find the equation, or whatever x value we get is basically going to be the equation of the vertical asymptote. Now to find horizontal asymptotes, I'm going to teach you a shortcut. Okay. So the first one is that when the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote of y is equals to 0 exists. Okay, so let's take an example. Okay, this one, 1 over y is equals to 1 over x minus 3. Okay, so what is the degree of x in the numerator? We don't have an x in the numerator, which means the degree of x is 0 in the numerator, and in the denominator, the degree of x is 1. So when the degree in the numerator is less than the degree in the denominator, the horizontal asymptote of y is equals to 0 exists. Okay, so this is a rule that you have to memorize. So in this case, we have a vertical asymptote of x is equals to 3. And for horizontal asymptote, we are going to compare the coefficient, the powers of x. If the power of x in the numerator is smaller or less than the degree in the denominator, then the horizontal asymptote of y is equals to 0 exists. Okay, so these are the two asymptotes for this function. Okay, what is the second scenario? When the degrees are equal, the horizontal asymptote is going to be the ratio of the coefficients of x. Okay, so we're going to use this example, this last one here. Okay, so 3x squared plus x minus 5 over x squared plus 1. Okay, in this case, the degree is x squared and the degree is x squared, right? They're equal. So what is the horizontal asymptote going to be? It is going to be the ratio of the coefficients. So in this case, it's going to be 3 over 1. So the horizontal asymptote is going to be 3 over 1, which means y is equals to 3. Okay, let's do another example if you're confused. Wait. Okay, so see, if we have a function y is equals to x minus 2 over 3x, and the examiner asks you to identify the asymptotes of this function. So to find the vertical asymptotes, what are we going to do? We are going to put the denominator, we're going to set it equal to 0. So x is equals to 0. So what is the vertical asymptote for this function? X is equals to 0. Okay, what about the horizontal asymptote? For horizontal asymptotes, we compare the powers. So the power is 1 in the numerator and the denominator. So what are we going to do? We are going to take the ratio of the x's. तो हमारा यहाँ पे क्या है रेशो? x के साथ ऊपर कोएफिशिएंट क्या है? 1. And what is the coefficient of x in the denominator? 3. So what is going to be our equation for the horizontal asymptote? 1/3. Okay, so this is the vertical asymptote and this is the horizontal asymptote. तो आपका ग्राफ पता है किस तरह का बनेगा? Very quickly. Again, this is not for me to teach in this video, but very quickly I want to tell you. So आपका f of x or y, this is going to be x, okay? So your vertical asymptote is at x is equals to 0. So this is your vertical asymptote. And your horizontal asymptote is at y is equals to 1/3. So if this is 1 somewhere here, y is equals to 1/3. Okay, so this is your horizontal asymptote. And your graph is going to be something like this. So it's going to be near something like this. ठीक है यहाँ पे और फिर यहाँ पे इस तरह का ग्राफ बनेगा. I hope it is clear. So for vertical asymptotes, you have to set the denominator to 0. For horizontal asymptotes, you have to compare the degree of the top of the numerator and the denominator. So a quick recap or basically the summary. For horizontal asymptotes, set the denominator and for vertical oh, I'm sorry, girls. So for vertical asymptotes, you have to set the denominator to 0. For horizontal asymptotes, you have to compare the degrees of numerator and denominator. Okay, in case the degree in the numerator is less than the degree in the denominator, the horizontal asymptote of y is equals to 0 exists. If the degrees are equal, the horizontal asymptote is going to be the ratio of the coefficients of the x with whatever degrees, highest power degree exists, okay? Now, the third case scenario, when the degree in the numerator is greater, then we get a slant line or an oblique asymptote or something that is not a part of our syllabus. Okay, so we are not going to touch upon that. However, one important thing that I want you to understand is what happens if they add something to your reciprocal function. So for example, we have 1/x plus 4 plus 1. Okay. Now in this case, vertical asymptote will be the same. We're going to set the denominator equal to 0. And we're going to find the equation of our vertical asymptote, which is x is equals to -4 in this case. What about the horizontal asymptote? So let's compare the degrees. Okay, so the degree in the numerator is less than the degree in the denominator. So for this equation, this part of the graph, the horizontal asymptote is going to be y is equals to 0. Okay, so what is it going to be? Y is equals to 0. However, we have a plus 1 here. So what happens is that we are going to write 0 for this part, and then we have a plus 1. Okay, so what is our horizontal asymptote going to be? Y is equals to 1. ये बेसिकली होता इसलिए क्योंकि देखो आप 1 over x plus 4 का ग्राफ अगर बना रहे हो and then you're asked to draw the graph of y is equals to 1 over x plus 4 plus 1. It means your entire graph is going to shift up by 1 unit. ठीक है, तो आपका फिर asymptote भी 1 unit ऊपर चला जाता है. ठीक है? Very quickly, another example to make sure that you understand. Y is equals to 2 over x minus 2 minus 3. Okay, so what is the vertical asymptote in this case? We're just going to set the denominator to 0. So x is equals to 2 is the vertical asymptote. What about the horizontal asymptote? So if we look at this part, since the degree in the numerator is less than the degree in the denominator, it is going to be y is equals to 0 and 0 minus 3 is going to be 0 minus 3. So y is equals to negative 3 is the equation of the horizontal asymptote. All right, now let's move on to exponential functions. Exponential functions, they look something like this. So y is equals to a raised to the power x, and sometimes they have an additional constant added, but we will get to this after discussing the basic exponential function. So where a is greater than 0 and a is not equal to 1 and x is any real number. Okay, so A basically affects the stretch or flip of the graph. B is the base, and K, the constant which we are going to get to in a while, is basically it's a constant that shifts the graph up or down. Okay, now here's the key thing to remember about exponential functions, that they always have a horizontal asymptote. Okay, let's have a look at a simple exponential function. For example, y is equals to 2 raised to the power x. Now, if I ask you to sketch it or draw the graph, what are we going to do? We are simply going to construct a table with x value and the resulting y values or the function values of y or function. So -1, -2. So if you substitute 2 raised to the power 2, you get a 4. 2 raised to the power 1 gets you a 2. 2 raised to the power 0 gets you a 1. What about 2 raised to the power -1 and 2 raised to the power -2? So we know through the laws of indices that if a power has, a base has a negative power, what it actually means is that we reciprocate the power, the fraction, and the power gets positive, right? So 2 raised to the power -1 means 1 over 2. Similarly, for 2 raised to the power -2 means 1 over 2. Power becomes positive, so we have 1 over 4. So try and understand your results. This graph will keep increasing as x gets bigger, right? So the graph is going to keep increasing. But as x becomes more and more negative, the graph gets closer and closer to 0, but it's never actually going to cross or touch 0. Okay? As the negative number increases, the value gets smaller and smaller, getting infinitely closer to 0, but it will never touch 0. So what is your asymptote going to be in this case? So see, if this is your graph, I need to move this. Okay? It's actually not accurate because ये graph यहाँ से ऊपर जा रहा है, which is not right. So I'm going to redraw the graph. So the graph is going to be something like this. So it's going to get infinitely closer to y, but it's not actually going to cross it or touch it. Okay, so what is our asymptote going to be? It's going to be, so it's going to be our x-axis, which is y is equals to 0. Okay, I hope you understand why. So no matter how negative the value of x will become, we are going to reciprocate it and we will have a positive number. The number is going to become smaller and smaller and it will approach almost 0 but never 0. Okay, now let's have a look at how to find asymptotes of exponential functions. So the first thing to remember here is that exponential functions only have horizontal asymptotes. So as the value of x increases, our graph is also going to extend. Now the trick here, or the key here to find asymptotes is that the number basically that is added or subtracted to the exponential function is going to tell us about the asymptote. So for example, y is equals to 2 raised to the power x. Now what is being added in this function? Nothing. Plus 0, right? So our asymptote is going to be y is equals to 0. Okay, let's do another example. If the equation of our graph is y is equals to 2x plus 1, so what is our asymptote going to be? Y is equals to 1. Okay, so whatever is added to our I will explain why this is the case, but for now, just learn this shortcut. Okay, so whatever is added to our exponential function is going to be the asymptote. Okay, let's have a look at another example. 3x plus 2 minus 4. So what is your asymptote going to be? Whatever is in the power, whatever is the exponential function, we don't care. Our asymptote is always going to be the number which is being added or subtracted in our exponential function. So the equation of the asymptote is going to be y is equals to negative 4. Okay? Okay, let's see if y is equals to 4x plus 1. Come on, girls. Think about it. What is the horizontal asymptote going to be? Since 0 is being added to the exponential function, our asymptote is going to be y is equals to 0. It doesn't matter what is happening in the power. We need to see what constant is being added or subtracted in our exponential function. Chalo, let's try a slightly trick question. Y is equals to negative 1 plus 5x plus 1. Okay. So I hope all of you are able to figure out that it means exactly this. So our horizontal asymptote is going to be y is equals to negative 1. Okay? So what is the shortcut? You need to take the help of the constant which is being added or subtracted in the exponential function to figure out the asymptotes. If nothing is being added or subtracted, then our asymptote is going to be y is equals to 0. Okay, now why is this the case? ये देखो, अगर आपका हम ग्राफ ड्रॉ करते हैं y is equals to 2 raised to the power x, ठीक है? And you sketch it here. Okay, wait. Okay. And let's just figure out the y-intercept. So for y-intercept, we put x is equals to 0. So 2 raised to the power 0 is 1. So our y-intercept is 1. 1, 2, 3, 4, and so on and so forth. So basically, our asymptote is going to be y is equals to 0. Okay, what is our, because it is 2 raised to the power x, what is being added or subtracted? 0. So our asymptote is going to be y is equals to 0. Let's highlight that. This is your horizontal asymptote for this exponential function. Now let's imagine that the examiner gives you the function y is equals to 2 raised to the power x plus 1. What happens now? Okay, this is, I don't know why, but I have this feeling that the examiner is going to test you on this particular concept in one way or another. Maybe they'll ask you to find the asymptote, or maybe sketch the graph of an exponential function where a constant is being added. क्योंकि इस साल अभी सिलेबस में उन्होंने ऐड किया है आपके एक्सपोनेंशियल फंक्शंस पहले सिर्फ ये तो उन्होंने अब ये कहा कि कोई कांस्टेंट भी ऐड हो सकता है सो प्रोबेबली सो मेक श्योर दैट यू अंडरस्टैंड नाउ व्हाट हैपेंस इफ ओके ये हमारा था ना 2 रेज़ टू द पावर x अब अगर हमें वो कह रहे हैं आपने ग्राफ ड्रॉ करना है 2 रेज़ टू द पावर x प्लस 1 सो व्हाट हैपेंस हमारे ये वाले आंसर्स तो सेम रहेंगे प्लस 1 हो जाएगा राइट हर चीज में प्लस 1 सो दिस विल बिकम 5 this will become 3, this will become 2. So everything is shifted. This will become 1 whole 1 over 2. This will become 1 whole 1 over 4. So what happens is that your entire graph gets shifted up by 1 unit. ठीक है? और आप ये देखो कि आपका intercept भी 1 unit ऊपर चला जाएगा. So if you place x is equals to 0, so what is your y-intercept now? Y is equals to 2. So आपका graph एक यूनिट सारा ऊपर चला जाएगा exactly 1 unit ठीक है so if everything gets shifted up by 1 unit what about the asymptote the asymptote is also going to shift up by 1 unit ठीक है आपका asymptote क्या हो जाएगा y is equals to 1 so working तो मैंने इसकी आपको समझा दी थी I hope you understand the reason for this working ठीक है I always think that if you understand why you're doing something in maths rather than just trying to memorize stuff it's going to stay with you ठीक है so do we why do we calculate the asymptote by looking at the constant क्योंकि आपका कोई भी एक्सपोनेंशियल फंक्शन हो जाए कोई भी एक्सपोनेंशियल फंक्शन हो जाए 8 raised to the power x 10 raised to the power x the intercept y intercept will always be 1 because when you're going to substitute x is equals to 0 you're going to get 1 10 raised to the power 0 तो आपका कोई भी एक्सपोनेंशियल फंक्शन हो आपका y intercept हमेशा 1 होता है but when you add a constant or subtract a constant then your entire graph shifts up or down by that constant तो आपका फिर asymptote भी उसी तरह shift करता है. Alright, before we wrap up, let's quickly revisit what we have covered in this lecture. We started off by understanding what an asymptote is, a line that a graph gets closer to but never touches. Then we looked at reciprocal functions and how to find vertical asymptotes by setting the denominator to 0 or by comparing the degrees in the numerator and the denominator. We also saw how squared reciprocal functions behave similarly, and finally we explored exponential functions, which always have a horizontal asymptote until and unless stated otherwise in the question, usually determined by the constant value in the equation. Take a minute now to go back and rewatch any parts you didn't fully catch, especially the examples. The more you see them, the easier it all gets. Remember, this stuff can feel tricky at first, but the fact that you're still watching means you're committed, and that's the biggest step. You're doing a great job, so keep going. If this helped, please give it a thumbs up, leave a comment with your questions, and don't forget to subscribe for more walkthroughs just like this. See you in the next video. Good luck.